Hi John, how's it going? So this is the introduction to chapter 13, which are trig equations. I actually really like this chapter. I think it's really fun because it's actually really similar to what you've done in just algebra, pretty basic stuff. You're solving equations just like, x plus 2 is equal to 5, except for the fact that instead of an x, you're going to have a sine theta or a cosine theta. But it's really, really easy, I think, because it's familiar stuff that you've seen before. So let's just start off with first degree trig equations. So when I mean first degree, I just mean that it's x to the power of 1 right here. So instead of x squared, it's just x. Okay, so first degree trig equations. This is a first degree just normal equation, and this is a first degree trig equation, and you solve them exactly the same way. So over here, to solve this equation, I would add 1 to both sides, and I would have 2x is equal to 1, and I would divide by 2 on both sides, and x is equal to 1/2. Okay? Now let's see how that would work with a trig equation over here on the other side. This time, same exact thing. Let's add 1 to both sides. We have 2 cosine theta minus 1 is equal to 0, so we're adding 1. 2 cosine theta is equal to 1. I want to get this cosine theta all by itself, just like I was trying to get that x by itself. Now I want to get the cosine theta by itself. So I'm going to divide everything by 2. Cosine theta is equal to 1/2. Okay, now the only difference between solving first degree equations and solving first degree trig equations is that once you get to see cosine theta is equal to 1/2, we don't care what cosine theta is, we want to know what theta is. So this is where I would pull up my magic table and figure out what theta is when cosine is 1/2. So let's figure out what angle that we're actually talking about here. So let's make a magic table really quick, just because it's always good to remind ourselves about how to do these things. Let me just make us a grid really quick. Alright, so we have sine, cosine, and tangent. Now, always remember that the order that you put these in are extremely important. If you put them in the wrong order, then you're not going to get the right answers because your method isn't going to work. So sine always comes before cosine. We're looking at 30 degrees, 45 degrees, and 60 degrees. Or in radians, if you want to think about it that way. This is pi over 6. This is pi over 4. And 60 is pi over 3. Just in case. I always kind of just like to throw the radian thing in there, just in case you ever see something like that. Alright, so how we make this table, you do 1, 2, 3, 3, 2, 1. Everything is divided by 2, and then there are radicals that go over the 2's and 3's. Now, tangent is the one that's hard. It's the one that you have to kind of sort of memorize on your own, which is unfortunate, but ooh, that was long. There's really no other good way of memorizing this. This is radical 3 over 3. And then I kind of say, oh, okay, radical 3 over 3, that kind of looks like it would be a 1, because radical, 3 over 3 kind of looks like it would be a 1. But it's not a 1 just because there's a radical 3 in the denominator. That's how I remember it, but you can do whatever you want. Okay, so this is our magic table. So we're looking for cosine theta is equal to 1/2. So here is when cosine is 1/2, right up here at 60 degrees. So I'm going to go back. theta is equal to 60 degrees. Now what you have to ask yourself is that the only place where cosine theta is equal to 1/2? Is that the only place? Well, actually, cosine theta is equal to 1/2 in, all 4 quadrants. Remember, because it's 60, and then it's all the cousins in every single one of the other quadrants. But because that's a positive 1/2, that means that we're only going to be a positive 1/2 in 2 out of the 4 quadrants. So whenever you're doing questions like this, you always do, all students take calculus. You say, okay, my answer is where cosine is a positive value. So where is cosine going to be positive? It's going to be positive up in the 1st quadrant and in the 4th quadrant. So that's where I got my 60 from. My 60 was my answer up here in the 4th quadrant. And then using my reference angle formulas, so theta, 180 minus theta, 180 plus theta, and 360 minus theta. That's how I figure out my other answers. So right up here, theta is 60 degrees, and then to get my answer in the 2nd quadrant, I do 360 minus 60, which is 300 degrees. So this has 2 answers. Or you could have used your calculator. You could have said, all right, cosine theta is equal to 1/2. So I'm going to type in here 2nd cosine 1/2. Whenever you know what cosine or sine or tangent is equal to and you're looking for the theta, you always do 2nd cosine or 2nd sine or 2nd tangent. And 2nd cosine of 1/2 is going to tell me 60 degrees. It tells you what the angle is. Okay, so that gives you your first one, and then 360 minus theta gave you your 2nd answer. So this is exactly the same thing as solving a normal equation all the way up until you get to the end. Then at the end you just have you have to figure out the 2 answers that are possible, okay? But solving the actual equation itself is exactly the same as something that you've already done for years. It's really, really easy. Let's see. Let's try another one. Okay. We got 2 more examples. So 3 sine theta minus 5 is equal to 7. So my variable in this equation is the sine theta. This is what I want to get all by itself. So how do I do that? Just like any normal equation. I'm going to add 5 to both sides. I don't know why this is not up. I'm going to add 5 to both sides. So 3 sine theta is equal to 12. Now I want to get that sine theta all by itself, so I'm going to divide both. Did I just write 1/2 when I meant 12? Oh my goodness. Absolutely losing my mind. I'm sorry. That is a 12. Now I'm going to divide each side by 3 to get the sine theta all by itself. So sine theta is equal to 4. Now watch what happens when I put this into my calculator. I know that 4 certainly is not one of the answers that I have on my magic table that you can look right here. See, 4 is definitely not here. So because I don't know what it is, I'm going to do 2nd sine 4. Close my parentheses and hit enter. Watch what happens. Error in the domain. So something happened. This doesn't work. It doesn't give us an answer. So why do you think that is? I don't really know why Ms. Tompkins put this question so early in the chapter, because it's kind of hard to think about. But let's go back to graphing a sine function. Sine function is what you did in chapter 12, where a sine starts at 0, ends at 0, goes through 0 in the middle, it hits its maximum first, and then it hits its minimum second at -1. So if we look at this graph, if we look at this picture, why do you think, and keep in mind that the theta are the x values right here, why do you think sine theta could never equal a positive 4? Well, the reason why is because sine theta lives within this tiny little range or domain between positive 1 and negative 1. Sine doesn't go anywhere, past that. I mean, certainly other things that we graphed might go higher and lower, but this is just normal sine. Normal sine doesn't go higher than 1 and it doesn't go lower than negative 1. So sine theta is equal to 4. That theta does not exist. Theta is equal to does not exist. Okay? Whenever you get an answer that is greater than 1 or less than negative 1, your answer is your answer is that it does not exist. Okay? Let's try a different one. Hopefully this one actually gives us an answer. Let's see. Alright, so 3 tangent theta minus 5 is equal to 7. So I'm going to do the same thing. I'm going to add 5 to both sides again. This time I'm actually going to write 12 instead of 1/2 though. So 3 tangent theta is equal to 12. Divide by 3 on both sides, and you're probably thinking, wait a second, this looks really familiar. Didn't we just do this, and didn't you just tell me that the theta doesn't exist? Well, let's see. Tangent theta is equal to 4. I'm going to go over here. Second tangent 4. Hit enter. Our answer for theta is 75.96. Now, why on earth did that work? Well, the reason why, if you had sine theta is equal to 4 or cosine theta is equal to 4, the reason why that doesn't exist is because it lives between positive 1 and negative 1. If I went down here and I graphed out what tangent looks like, you remember how tangent flows along those asymptotes and it actually goes off into positive infinity that way, and it goes down to negative infinity this way. So tangent doesn't have, limits that it's bound by. Over here, sine can't go outside of this area, but tangent goes on and on forever for both the x-axis and the y-axis. So that's why this works and that one doesn't. So we actually got an answer when we were looking at tangent, and we didn't get an answer when we were looking at sine. We would not have gotten an answer if we looked at cosine either. Now, don't forget that just because you got your answer doesn't mean that you're done, because all students take calculus. We got tangent theta is equal to a positive 4, so that means I'm going to have 2 answers. You're always going to have 2 answers when you're doing this kind of stuff. One answer is going to be up here in the first quadrant. The other is going to be down here in the third quadrant where tangent is positive. So my first answer is 75.96. And then my second answer down here in the third quadrant, that is 180 plus theta down in the third quadrant. So I'm going to do 180 plus second answer, just because I already have that decimal sitting right there. Hit enter, and that's 255.96. Those are my 2 answers for theta. Those are the 2 angles that would work within this equation. Okay, and we normally write that out by putting it in brackets. Thank you very much. That one's posted. Awesome. Oh my gosh, I did not mean to do that. Whoops. Okay, we normally write these out in brackets. Okay, so hopefully the next slide gives me a little bit more room to work. Okay.